All right, let's look at number 6. So we have a push broom of mass M is pushed across the rough horizontal floor by a force of magnitude T, directed at an angle theta as shown above. Coefficient of friction between the broom and the floor is U. Frictional force on the broom is a magnitude of what? All right, well, let's draw a free body diagram for this box here. Now, if we look at it, this force going from top left, bottom right, I'm going to draw it instead. I'm going to draw it like this. The same idea, right? Same idea. I'm just starting the force at the origin of the box, but it's still pushing bottom right. Same idea. So this force we'll call T. Even it's not a tension force, they're just labeling it T, so we'll label it T, even though it's just an applied force. And we could break this up into dy and dx because we know this angle right here is theta. So tx is going to be equal to the cosine theta, and the ty is going to be equal to the sine theta, since this is opposite and that's adjacent. Oh, can't see. All right, now we also know this box has a weight pulling down. So it has a force of gravity, which we should know by now is equal to mg. It's going to have some sort of frictional force opposing the motion. And it's going to have a normal force pushing upwards. And that's going to be equal to, it's got to be equal to these two forces added together, because the box is not accelerating up or down at all. So we know that the normal force is equal to F sub g plus Ty, which is T sine theta. F sub g we also know is equal to mg, so we could also say that the normal force is equal to mg plus T sine theta. So the frictional force, if we remember our friction equation, is equal to the coefficient of friction times the normal force, and we know that the normal force is the same thing as mg plus T sine theta. So the force of friction then can be found by taking the coefficient of friction and multiplying it by mg plus T sine theta. So the answer must be A.